Let's walk through it. First, head into Tuning, then the Tuning Suite. From here you'll either build a new profile or load one that already exists. I'm loading one I've already built. The moment that profile opens, it tells you exactly where things stand. Need to make a change? Just go to the Hardware tab. Outputs, Inputs, DSP, your whole library, it's all right there. Here's the part that matters most, your measurements have to be done. That's your ohms, your impedance, your voltage output. Skip it, and the system assumes your gain is sitting at 100%, which means you lose volume, and you lose headroom. Scroll down and you'll find a few ways to view your setup, a detailed per amp breakdown with everything laid out, or a view by speaker card. Either way, define your roles properly, speaker type, location, size. Pull it straight from our library, or key it in yourself. Once that's set, you move to hardware wiring, and this step is non-negotiable. Define whether it's bridged. Map every speaker to the correct amp. Skip this, and you're not looking at a rough tune, you're looking at blown speakers. The system can't read the physical world for you. You have to tell it. See how these two are grouped down here? That's two speakers wired in parallel on one channel. Above it, those are simply bridged. You can group channels however makes sense for your install. Once you're through setup, this panel flags problems before they become expensive ones, overpowered channels, real risk of speaker damage. If voltage isn't entered, the system has to guess. So it falls back to the OEM factory standard and calculates the safest path it can. Leave that blank, and you're gambling. Now, to the tune itself. Open the Tune button and you've got three paths: manual, semi-auto, and tuning tools, your built-in calculators for port velocity and everything else you need, running live through the system. Let's run one. I'm loading my Giza Glide profile, and here's why that matters for a shop. A tech can switch between saved tunes without starting from scratch. Someone else builds the speaker and amp profile, you just tune. Next, confirm your microphone setup, listening distance. One thing this system will never do is shut your bike or car off for you. If something goes wrong, that's on you, hit the kill switch immediately. It should run clean, but Murphy's Law never clocks out. Set your target curve, vehicle type. Mine's a bagger, so I scroll to bagger, under touring, right at the top. Now connect the DSP. There it is, connected. Here's the mixer. This is where it tells you what needs adjusting, because this is exactly where your voltage gets controlled. Now the RTA, which microphone am I running? In this case, a full microphone array, multiple mics working together. Pre-flight is set, that's the speaker test, so let's hit start RTA. Everything's staged, DSP connected, tune loaded, vehicle profile set. Time to move. First real step, test every single speaker. That's the pre-flight, hit start. It'll confirm your safety parameters one more time, because a blown speaker is not the goal: max safety volume, target max SPL, hardware limits, speaker nominal. Confirm it, save it. From here you choose your tuning order. Some techs like bass first, that's pure preference, the system doesn't care what order you pick. And here's the real difference: this isn't tuning one channel, checking the box, moving to the next. It's holistic. Every channel, listen to it once. It looks at each frequency across every speaker and asks, where should this sit, and where's it falling short? Every speaker owns a frequency range it's responsible for, that's how the correction gets made. One more briefing before we run it: resonance peak first, narrow cuts 3 through 8, multiple passes. Let's start channel 1. Hit start auto, and it generates a solo test a Euros channel 1 first, then straight through every channel after it. Six tests run on every channel. First up, ambient noise validation. Watch this panel A-Euro, it tells you exactly which frequency it's testing. This test is listening for rattle at -20 decibels. Next test, headroom A-Euro listening for clipping. Now it checks polarity. (800 Hz). Every speaker gets its own tested frequency range A-Euro. Right now it's my left bag, channel 2, testing that same left side speaker. It mutes every other channel before moving to the next speaker A-Euro, one at a time, no bleed. Now onto the mid-range speakers, channels 3 and 4, the lowest frequency pair in the set. Watch the frequency shift to match that speaker's range. Quick note on MIC placement, it's sitting at the rider's position, capturing everything from there. This system supports up to 32 microphones for a properly staged vehicle. Every so often it pulls a reference file A-Euro just to cross-check against an outside source. Worth noting, this line is the actual target curve I'm tuning to, a custom curve the system built from Black Betty. One pass gets you a baseline. Run more passes, and that curve gets smoother every time. Now channel 4, the other mid-range. I'm close enough to reach every speaker during pre-flight, so if anything sounds wrong, I hear it immediately. The AI gets it right almost every time, but not always, and it's built with backups for exactly that. If it does slip, it's usually headroom set a touch too high. The system has protections built in, but protections aren't a guarantee, so stay sharp. That yellow line A-Euro, that's your actual target. We're back. Every speaker just cleared pre-flight, so we move straight into auto-tune. This panel shows your hardware setup A-Euro, and if there's a gain issue, click here to remeasure voltage and ohms on the spot. Otherwise, the system runs with what it already has, and you can override it any time. Next, we continue the test. This is the optimization phase A-Euro, and it takes a few minutes, because it's running the full math, speaker setup, profile data, everything pulled from pre-flight, all optimized into the final EQ. This is AI-driven, and it typically wraps in 1 to 3 minutes.